Welcome to Gold Wine, crafted by Monoa Masud, your destination for quality education and enlightenment. Dedicated to fostering learning and growth, Gold Wine offers curated content designed to empower and inspire viewers of all backgrounds. Join Monoa Masud on this educational journey by subscribing today. Cheers to learning and discovery with Gold Wine.
Pressure indicator. Hey Goldwyn fam! Dive into the world of precision and control with our latest video on pressure indicators. Whether you're a seasoned pro or just starting out, understanding the significance of pressure indicators is key to mastering your craft. Join us as we explore their crucial role in various industries, unraveling the secrets behind accurate measurements and optimal performance. Don't miss out on this essential knowledge. Empower yourself with the insights you need to elevate your skills. Hit play now and let's unlock the potential of pressure indicators together. What is pressure indicator? A pressure indicator is a device or instrument used to measure, display, or indicate the pressure of a fluid or gas in a system. The primary purpose of pressure indicators is to provide users with information about the pressure conditions within a process, system, or equipment. 1. Analog pressure gauges. 2. Digital pressure indicators. 3. Pressure transducers. 4. Pressure switches and 5. Manometers. What is pressure indicator? Analog pressure gauges. Digital pressure indicators. Pressure transducers. Pressure switches and manometers. Analog pressure gauges. These are the most traditional type of pressure indicators. They consist of a dial with a needle that moves to indicate the pressure. A Borden tube is a common mechanism inside many analog gauges that translates pressure into mechanical movement. Digital pressure indicators. These provide a numerical display of the pressure value. They can offer higher accuracy and may include features such as alarms, data logging, or communication capabilities. Pressure transducers. These are sensors that convert pressure into an electrical signal. The electrical signal can then be interpreted by an indicator, controller, or data acquisition system. They are often used in industrial applications where electronic signals are preferred over mechanical displays. Manometers. These are devices used to measure the pressure of liquids and gases. They often use a column of liquid to indicate the pressure by the height of the liquid column. Pressure switches. While not strictly indicators, pressure switches are devices that trigger an action, like turning on, off a pump, when a set pressure threshold is reached. They typically have an indicator to show whether they are open or closed. How pressure indicator works. A pressure indicator is a device used to measure and display the pressure of a system, such as in hydraulic or pneumatic systems, pipelines, or vessels. The working principle and design of a pressure indicator can vary depending on the type of pressure being measured and the specific application. However, here's a general overview of how a pressure indicator typically works. Pressure sensing element. At the core of a pressure indicator is a sensing element that reacts to changes in pressure. This element may be a diaphragm, Borden tube, bellows, or some other mechanism that deforms or moves in response to pressure changes. Pressure transfer mechanism. The pressure sensing element translates the applied pressure into a mechanical motion. For example, In a Borden tube pressure gauge, the tube straightens or bends as pressure is applied, and this mechanical motion is transferred to a pointer. Pointer and dial. The mechanical motion from the sensing element is often connected to a pointer that moves across a calibrated dial. As pressure changes, the pointer moves to indicate the corresponding pressure value on the dial. Display. Modern pressure indicators may have electronic components that provide digital readouts or integrate with control systems. In these cases, the mechanical motion from the sensing element is converted into an electronic signal, which is then displayed digitally. Safety and calibration. Many pressure indicators incorporate safety features like overpressure protection mechanisms to prevent damage to the sensing element or the indicator itself. Additionally, periodic calibration ensures that the pressure indicator provides accurate and reliable readings over time. Types of pressure indicators. There are various types of pressure indicators, including mechanical pressure gauges. These use mechanical components like Borden tubes, diaphragms, or bellows to measure and display pressure. Digital pressure indicators. These use electronic sensors and display pressure readings digitally. Differential pressure indicators. These measure the difference in pressure between 2 points in a system. Pressure indicators work based on various principles, depending on their design and type. Here's a breakdown of how some common pressure indicators work. Borden tube mechanism, analog gauges. Digital pressure indicators. Pressure transducers. Manometers. Borden tube mechanism, analog gauges. Working principle. The Borden tube is a curved, hollow tube made of metal, typically bronze, brass, or stainless steel. When pressure is applied to the inside of the tube, it tends to straighten out. This deformation causes the free end of the tube to move, which is mechanically linked to a pointer on a calibrated dial. As pressure changes, the tube's deformation changes, causing the pointer to move across the dial, indicating the pressure. Components. Borden tube. Curved, hollow tube. Linkage system. Connects the Borden tube to the pointer. Calibrated dial. To display pressure values. Digital pressure indicators. Working principle. Digital pressure indicators utilize electronic pressure sensors, like piezoelectric, capacitive, or strain gauge sensors, to detect pressure changes. The sensor converts the pressure into an electronic signal. This electronic signal is then processed and displayed digitally on an LCD or LED screen. Components. Electronic pressure sensor. Signal conditioning circuitry. Digital display, LCD or LED. Pressure transducers. Working principle. A pressure transducer converts pressure into an electrical signal. Depending on the design, it may use piezoelectric crystals, strain gauges, or capacitive elements to convert mechanical pressure into an electrical output. This electrical signal can then be amplified, conditioned, and transmitted to monitoring or control systems. Components. Sensing element, e.g., strain gauge, piezoelectric crystal. Signal conditioning circuitry. Output interface, analog or digital. Manometers. Working principle. A manometer measures pressure by balancing the pressure of a fluid column against the pressure of the system being measured. There are various types of manometers, including U-tube, inclined tube, and well-type manometers. In a U-tube manometer, for instance, the pressure difference between the system and a reference is indicated by the difference in fluid levels in the two legs of the U-shaped tube. Components: transparent or translucent tube containing a fluid, usually a liquid like mercury, water, or oil. Scale or graduated markings to measure the height difference in the fluid columns. Connections to the system being measured in the reference. In summary, Bourdon tube mechanism uses a curved tube that straightens under pressure, mechanically linked to a pointer on a dial. Digital pressure indicators utilizes electronic sensors to convert pressure into a digital display. Pressure transducers converts pressure into an electrical signal, which can be further processed or transmitted. Manometers measure pressure by balancing against a column of liquid, with the difference in fluid levels indicating the pressure difference.
Thank you.